Alright guys, so here's 8.2. We went through these today and figured them out. We went through the domain and the range of the functions, or just the domain I should say. And then here, what are the sine, cosine, and tangent? Where are they positive or negative? Basically, by going through the unit circle, we know that sine is positive in the first two quarters, and negative in the last two quarters, because remember sine is going to be your y, so of course positive is going to be up here, negatives are going to be down here. Cosine is going to be positive in the first quarter and the last quarter quadrant, because we know that cosine represents the x values, and tangent, because it represents x over y, will be in quadrant 1 and in quadrant 3, because both x and y here are negative, which means that negative over negative is positive. And the same goes for the negatives. Okay, so you guys can write those down. And then I gave this to you as homework for tonight. I'm just going to show you the answers. You can stop the video to kind of write them down and make sure that they're correct. We will go through them a little bit in class, not all of them, but a nice chunk of them. And then now we're going to move on to the next section, which is graphs of the sine, cosine, tangent functions and their inverse, the inverses of each other. All right, so before we actually get started, we do have to go over some of these definitions. So first of all, the periodic function. Periodic function, they're basically asking you, when does the function repeat its values? So when you have a wave, when does the wave start just repeating and the rest of it is just the same? So a periodic function means it repeats its values in regular intervals, creating a wave-like graph. When we start looking at these functions, the function notation for this will look like this. It will be f of x will equal a, remember your a is basically identifying if it's negative or positive, times the actual function. And what this f is it can be, the sine, the cosine, the tangent, the cosecant, the secant, or the cotangent. So whatever is written in there, times, we will have b x minus h plus k. And we'll identify what that b is in a minute. But it's going to be a number that is in front of x inside the parentheses. And then the h and the k is what it's always been. This will always be your left or right, your horizontal displacement or translation, and then this will be your up and down. All right, which brings us to the next, which is period. Period, the period is the horizontal length of one cycle of a graph before it repeats. So the period in the majority of our functions will be given in this formula, 2 pi over the absolute value of that b value that we talked about here. okay? Now, in tangent and cotangent, though, it's a little different. It will just be whatever your pi is over the absolute value of your b. All right, next up, we have the amplitude. The amplitude is half the vertical distance between the absolute max value and the absolute min value of the graph. All right, so our amplitude will be the absolute value of whatever our A is, and that is going to be for sine and cosine. The reason I'm not giving you the rest of them is actually we will not be asking you to graph the other functions by hand right now. All right, the phase shift. The phase shift, basically aka the horizontal movement, left or right, and you guessed it, it is represented by whatever your h is. So if you have x minus h, then of course it's going to move h units to the right. And if you have x plus h, it's going to move h units to the left. So nothing new here. Same with the vertical shift. The vertical shift is up or down. And with this one, if you have a plus k, it's going to move k units up. And if you have minus k, it's going to move k units down. All right. The reason why I didn't put this video up earlier is because I actually want to give you guys a different worksheet to graph these functions rather than having a regular grid plane. I want you guys to have on hand the actual graphs for trig functions where the x values are the radians on the unit circle. So I do want you guys to have that, so that's why we will go over this tomorrow, or I will pass it out to you tomorrow, and if we get to it, we get to it. If not, then you have this video to finish it off. All right, so I'm going to move this really quick, and in order to identify what I have done is I have printed out a few mini unit circles so that we can refer to for each of these functions. All right, so first of all, we want to start off with the sine function. So